For 3, we're going to be multiplying 7 and 234 thousandths and 1 and 23 hundredths together. But the reason why we can ignore the decimal places and just move them to get our whole number, move them to the right to get your whole number, move it down, count how many times you moved it, and moving it back the same amount in numbers is because we essentially wanted to change it into a whole number to be able to multiply correctly, and then we just moved back the decimal, the amount of spaces. So I'll show you exactly what that means. 7, 2, 3, 4 over 1 times 1 and 23 hundredths. We're going to multiply this by 1,000 over 1,000 to get rid of our decimal. 100 over 100 to get rid of that decimal. And then we have these two equivalent fractions. Okay, so multiplying across, you're going to get this number. Okay, so we want to change this into a decimal again, which is what we originally had when we first started with, because right now it's a fraction. And to do that, we know by the power of 10 that we can move there's 5 zeros, so we're moving 5 decimal places to the left. So that is how we get our answer like we did in the original standard algorithm. Because we did this over here. We multiplied it, which is moving the decimal to the right a certain amount of times to be able to get these two whole numbers. And then we moved it back to the left the certain amount of times, which is 5 to the left to get our answer. Number 4, I'm going to explain why the traditional algorithm works when we move the decimal place to make it a whole number, and then we move it the same amount in the dividend as well. So when we're dividing 3 and 38 hundredths divided by 2 and 6 tenths, we can rewrite that as a fraction. It'll be the same as 3 and 38 hundredths with a fraction bar, which means divided by definition, 2 and 6 tenths. And we want to make this a whole number, so we're just going to make an equivalent fraction like that. So 10 over 10, if we multiply it by that, we're moving the decimal one place to the right, just like we did over here. Okay. And then 26. And then if we divide that the long division way, we're going to get the same answer. (1.3) and 1.3. So essentially, because of equivalent fractions, we know that either way we do it, it's going to give the same answer. Because of the moving of the decimal over here, that's exactly what we were doing over here.